Again, I'd like to welcome you to tonight's lecture, which is the fifth and final lecture of the 21st season of the Food for Thought lecture series, hosted by the Faculty of Agriculture and Environmental Sciences of McGill University. Our theme this year is Building Back Better, How to Sustainably Restructure Our Way of Living. Tonight's speaker is Dr. Michael Jemtrud. He's an associate professor in the School of Architecture at McGill, the director of the Facility for Architectural Research in Media and Making, or FARM. He's a founding member of the Decarbonized ARchitecture and Building, or DeCARB research group. Michael's trained in design and construction techniques for high performance buildings, such as Passive House, and is also skilled in multi-stakeholder consultation, having worked with various communities on construction projects across Quebec. In other words, Michael loves to work with other people to make cool buildings. His primary mode of research and teaching is to design and construct things at full scale using novel technologies in ways that address climate change. For instance, he led a large student team who built an award-winning net zero energy house for the 2018 Solar Decathlon in China. His current research focuses on deep energy retrofit and renovation of existing buildings as part of the decarbonization of the construction industry. So we could say Michael loves to work with other people to make cool buildings and save the planet. So I'm going to turn it over to Dr. Jemtrud now for his discussion of building environments, designing and constructing deep decarbonization pathways. Michael, take it away.
Thank you very much, Grant. Everyone hear me? Good. So I'll just start the screen share, I guess, right away. There we are. So is that good? Everyone see that?
Looks good.
Yeah. Excuse me. Well, thank you. This is really a pleasure to be crossing faculty, something that I've been looking forward to do for a very long time. I'm in the School of Architecture, which is in the Faculty of Engineering. And I've been working with Grant now for about a year, trying to set up some tangible research projects and initiatives out in at the MAC campus, some of which I'll talk about tonight. So let's just get right into it. So what I am going to talk about tonight is three intertwined initiatives. So there's the DeCARB research program, which is kind of the blanket research program that we have within the School of Architecture now, involving quite a few faculty members that I'll show later. I should say it's housed in the School of Architecture, but it really is meant to be interfaculty, interinstitutional, and quite a lot of industry partners as well. The second related theme that I guess falls within the DeCARB program is the Quebec Building Energy Retrofit program, which is a research program that I'm applying for right now. It started as a Hydro-Quebec Industry Research Chair proposal, but since the granting programs have changed quite a bit, it's kind of taken a new twist. So I'm still working on that, but I hope to submit that by the end of the, I guess, the term. And then the third initiative, which ties into all of this, is a large CFI grant, Canadian Foundation for Innovation grant, to build a new building out at MAC campus called the Building Architecture Research Node, which I will speak about. Now, collectively, I guess the big question for all of us is really trying to have a holistic consideration of the global warming potential of the entire building environments process. I say building environments process instead of architecture or engineering because it's a verb and a noun. So it is about buildings, of course, but it's also the entire process that we go through to build a building or a community or a landscape or anything that involves the built world. And within that, we're looking to formulate and establish some deep decarbonization pathways for the industry. Not just the architecture, engineering, construction industry, but also our associated industries, which are vast, but in particular the energy and the resource sectors. And one of the things that has, I guess, collectively frustrated a lot of us within the school is the fact that a lot of upstream, downstream impacts within our discipline are not accounted for in our methods and the way in which we design things. So we're really looking at showing the carbon equivalent upstream, downstream impacts of the total process. Again, that's why we refer to the building environments process. Next, the one thing we're really excited about doing, particularly with our colleagues out at the Faculty of Agriculture and Environmental Sciences, is trying to figure out how to synchronize some of these sectors to achieve greater reductions and possibly even greater sequestration opportunities. And that's one of the reasons why we're focused on forestry and wood right now. Within that, what do we do? Well, yes, we do build buildings. We prototype, we pilot, we demonstrate these solutions within communities, for communities, but we also have some basic scientific research and development of novel design, analytic, and assessment tools. Oops. So here's the team. It's big, and I'm not going to go through everybody's CV here because we'd be here forever, but we've a bit of embarrassment of riches within the School of Architecture. We're going through a generational change, and we've made some extraordinary hires over the last 5 years, which basically makes the school about 60 to 70% new faculty members. So it's a huge shift, huge shift. Sal Craig, I'll show some of his work tonight. He's an engineer, he's doing some amazing research in timber. Rosetta Elkin's a landscape architect who's doing a lot of work in coastal resilience strategies, forest ecosystems, things like that. Naomi Keene is coming here in January, actually, and I'll show some of her work that is tied to some of the work that Professor Keel Mo does, who came here a few years ago, as well as Theodore Varduli, who's more in the area of digital tools and techniques, but that's a big part of our research as well. Then like I said, we are working with people out at the Faculty of Agriculture and Environmental Sciences on our grants that we've submitted so far. The CFY one in particular, we have Professor Elena Bennett grant, of course, Professor Benoit Cote, and then within the Faculty of Engineering, again, we have Professor Susan Gaskin, Nick Luca, who's in planning and architecture, and another professor who's coming in September 2021, Philip Tidwell. And then there's another expanded team that is very international, actually. There's quite a bit of Canadian content too, but because of our focus on some of our research foci, I guess, there's quite a few Scandinavian collaborators, I guess, on this project. We're part of the Arctic Wood Architecture Network out of Aarhus, Denmark. So there's a lot of connections there as well. So what is DeCARB? There we are. Well, it's really, I'm not going to make it horribly complex or anything, but it's really looking at the building environments process as a full world system. So it's looking at all of the components that are part of our built environment that we call the technosphere, and how that interacts with the geobiosphere. Like I said, we have a great interest in wood and biogenic carbon related systems and issues. So, but it's not only limited to that. So it's an interdisciplinary and transcalar approach. We have people from Elena Bennett looking at huge ecosystem services, and Rosetta Elkin looking at coastal resilience strategies, and Nick Luca looking at communities, all the way down to Sal looking at very specific building techniques and technologies. And we're really trying to fill the knowledge and technology gaps that we see in the architectural engineering construction industry. One of the big points is that we've recognized all the different levels of uneven exchange, whether it be ecological, economic, or even in the metabolic rifts in the systems. And again, as I said before, we're very concerned about how a lot of these issues are routinely externalized in the research and design of buildings and urbanization. And these enabling externalizations are directly responsible for a lot of environmental and social degradations around the world. I'll speak a bit about that later. So we're looking to expand our typical disciplinary system boundary and as well into other disciplines, into other areas and at much larger scales. I already said that we're looking to develop the kind of technologies and knowledge, epistemological structures around the gaps that we see in the industry. So it's all about this sort of interaction between resources, energy, and building, and that it's always a bi-directional flow of these things, and they get intertwined in very complex ways. But we truly do believe that Canada, and particularly Quebec, is poised to achieve low to carbon negative modes of living if we can effectively integrate this range of necessary flow systems and carbon cycles. One example of that, for instance, is the global warming potential of some of the greenhouse gases that we're talking about. So this one in particular, sulfur hexafluoride, has a global warming potential of 22,800 times greater than carbon dioxide. So this is a component, a man-made component used a lot in electrical insulators for substations and semiconductors and such. As I work a lot with Hydro-Quebec, and as we in Quebec electrify everything, we think this is a great thing, but there's a lot of negative feedback loops that come with that. And one of them, this is one of the main ones, that this compound is hugely damaging to the atmosphere. And the more and more we electrify, we might be saving carbon equivalents on certain levels, but this one is really exacerbating another level of that. Other examples that we see in our own supply chain, for instance, is like sand. There's a global crisis in sand right now, and that has to do with concrete. For instance, China used more concrete in the first 3 years of this century than the United States did in the entire 20th century. So there's literally a sand shortage. There's a mafia around sand, and people are dying because of it. The sea around North Korea is having huge degradation problems. So when we specify concrete in our buildings, these are things that we want our students to be aware of, that it's not just about that thing in front of you. Cobalt, of course, in terms of still mined by hand, with like 25-year-old men dying in Africa and other places where it's mined. That's in our cell phones, that's in our electric vehicles. Other issues around forestation and deforestation. Everyone talks about planting billions of trees, but in the north, in Canada, for instance, in parts of it at least, reforesting would have a greater damage on global warming because of the albedo effect up there than actually leaving it deforest. So, sorry, what we're really talking about is this very thin layer of the atmosphere around the Earth that we have to locate architecture in. And it reminds me of a saying from my favorite artists, Tom Waits, when he was inducted into the Rock and Roll Hall of Fame. He said, songs are really just very interesting things to be doing with air. So I've kind of taken that to heart, and buildings are really just a very interesting thing to be doing with air. And I think it's an important mental shift to make for our students, for the profession at large, that although it's very concrete, we're dealing with social issues and things like that, there's these externalized effects that we have to be more aware of. And we need to have that kind of mental paradigm shift in order to think that way. So I'm going to go through this next section a little quicker because I think this is probably familiar to a lot of people, but we're really looking at carbon critical building environment process solutions. So as you know, probably that architecture is responsible, or buildings are responsible for a huge amount of the global emissions, and that's operational emissions. But even more importantly, as we get better and better with energy efficiency and electrification, and particularly in Quebec, because we have hydroelectric power, the embodied emissions in a building and in the whole process is even more important. a typical building actually over its lifetime has more embodied carbon and energy emissions than it does operational ones. So how do we expand the system boundary? Well, we're looking at, this is a typical life cycle analysis kind of diagram. And my colleagues like Naya McKenna and Sal and Keel Mo have developed some techniques and some methods that actually expand that system boundary and look at the actual work of the geobiosphere. So through energy analysis, they understand how much energy it took to grow a tree. And then it goes all the way to the other end where it's looking at capital and human resource expenditures and energies. These are some of the diagrams, and that the book in the middle, The Hierarchy of Energy and Architecture, Keel wrote, and the tools on the right, the SIVA tool and Clark's Crow are two actual tools that we use with our 3D modeling programs that Naomi developed in her PhD and will continue working on here at McGill. Sal Craig, amazing engineer, crossover engineer to architecture, which is actually quite rare in a lot of ways. And he's working on all wood constructions, along with tuning that with passive ventilation techniques to basically, he's found a way to use all wood wall construction to behave at levels, passive house levels of performance, really high performance enclosures, but they're all wood assemblies. So there's none of the other membranes and things that have a lot of high carbon content in them. He's doing this all with something that sequesters carbon instead. So he's looking at buildings as a global carbon sink, and that would be just a complete game changer in the industry. I show this because we're actually prototyping some of his technologies at a collaborating institution, Auburn University. They have a group called the Rural Studio, and they are one of the longest standing design build programs in the world and probably the best known. So they're prototyping these things for us right now because we don't have the capacity here right now, but I'll get to that because we're trying to change that. And then of course there's the design build stuff where we actually prototype and build buildings to prove our ideas, to prove our techniques and integrate the technologies that we're developing in the building itself, but also in terms of the design tools that we're developing, which I think is even more important. And the images you see on the left there, that's the building we built in China in 22 days, which was insane, and I'll never do that again. And then there's the Quebec Chair in Building Environments, which, as I said before, it started off as a Hydro-Quebec research chair, but it's also now got the Transition Énergétique du Québec people are supporting at the equal level of Hydro-Quebec, and then there's some industry partners as well. It's a 5-year research program, renewable, but the first 5 years we're focusing on building energy retrofit, and that's kind of my thing right now, my main focus right now. So the goal is to develop a Quebec building energy retrofit platform that we can actually roll out. Okay, it's something, the time is urgent and we really need to make this happen. So we're working very closely with all of the governmental people, which I'll speak about, that would be responsible for administering and incentivizing and subsidizing such a program. Our role in it is more about building the tools around this that would make it possible. You need upfront evaluation tools to find the right buildings to do. You need to be able to calculate baseline carbon levels in an existing building, because in the end, it's always a lot more sustainable not to build. I know that sounds funny coming from an architect, but renovation and keeping buildings is the best way to move forward. And within that also, we're developing kind of the co-design processes with the inhabitants and the owners and operators, as well as some of the technical solutions for prefabricated panelized systems, as well as the active systems. This is huge. I've been working on this for 2 years to get this going, trying to convince people that this is a good thing to do. And now virtually on every single national platform for a post-COVID recovery incentive, economic recovery plan, deep energy retrofitting buildings is always in the top 3. I mean, the Canadian government just announced another $2 billion in this area. And they're actually, that's on top of at least 12 billion that was already existing for this. So there's a lot of effort in this, a lot of interest in it. The thing is, we don't really have a platform in Quebec or Canada where we could roll this out right now. So that's what we're working to develop. These are some of the other recent announcements. I could show you a dozen of these right now. So one of the important parts of that is I want to make it clear too that we're looking at this from a social perspective as well, social and cultural and economic. Something that architects don't normally have a lot of, they're always aware of it, but they don't necessarily have a lot of expertise in it. But we're working with some people in School of Management and elsewhere to help us with this. So it's really looking at kind of the socio-technical dynamics, like people don't necessarily buy into, if you will, things like a deep energy retrofit program or high performance building or energy efficiency measures. And we have to understand why that is. And it's always very specific to a culture and a region and a place. So that's a whole system you have to sort of develop and understand and implement. Then there's the niche innovations, which I've already talked about a few of those, like Sal's monomaterial wall assemblies, some of the tools we're developing. And then there's this intertwining of what's called exogenous developments. So it can be a shock like COVID, like a pandemic, or it can be incremental, people just getting more and more aware of issues around the environment, for instance. This is a very simple slide. Basically, we have a lot of buildings that are built way before code was ever introduced in a serious way, and that we have 80–90% of the buildings that we have on the island, well, in North America right now, will be around in 2050. So new construction is going to be a lot of square footage around the world globally, but the reality is it pales in comparison to the existing buildings that we need to do something about. The other part of this is that these deep energy retrofits, as I'm calling them, are proven to create a much more resilient community. The buildings themselves are much more resilient. They can take extreme weather events better, and they're definitely healthier indoor environments. And that's a really key part, because that's come to light with the pandemic for sure, that the air quality measures need to be addressed. And then thirdly, because of, well, Hydro-Quebec, I've been working with Hydro-Quebec for a while, and they need us to be more energy efficient in Quebec if they're going to keep pace with the electrification of the province, as well as to continue to sell energy to New York for a lot more than we pay for it. So basically, a deep energy retrofit is wrapping an existing building in a new skin, and then upgrading its mechanical and its active systems, all of them. It could be your lighting too, etc. And as I said before, for me, one of the main non-energy benefits is the health and well-being, the increase in healthier indoor environments and the well-being of the occupants. But these are proven to be able to reduce energy demand by 75–90%. There's a lot of things you have to do to make these things work, but the main point of this slide is that they are Europe's been doing this now for a long time, about 15 years aggressively. And what they've discovered is there is no silver bullet here. That you have to design each solution for the region, for the province, if it's Belgium, it's not a problem. If it's the Netherlands, not a problem. It's very small, but here we have to make it very specific to the region. The other part of this is that you have to have the right building stock. In other words, you need to have a building stock that can be aggregated at a certain scale, so it makes it cost effective for the industry people to do it. They can't obviously lose money on it, and the government is not going to. It always requires some public sector money, but it has to be just a little bit to mitigate risk, and you have to lower the risk by aggregating buildings together. And then prefabrication is really important to this, because these panels, these systems are typically prefabricated in a factory. This is probably our biggest gap right now in Quebec. Although we have a very large prefabrication industry, they don't have the skill sets nor the desire really to do high performance construction, and no one really knows how to do the deep energy retrofit thing yet. But we're working with quite a few companies to expand their capacity. There's a whole bunch of benefits to prefabrication, but for me, one of the biggest ones is the fact that it can address our skilled labor shortage, which is serious here in Quebec. We're just not getting people going into the trades anymore. So part of this process is a digital process where you have to laser scan a building. You have to record the building very precisely in order for the panels to, fit basically to where all the windows and doors are. So this is typically one of the big barriers, and this is for adopting these strategies. And this is something I used to do quite a bit at my old lab in Ottawa, and we're working with them again to streamline this process. And then this is probably one of the most important components of the research program. And this is the carbon impact assessment tool. And this is something that, like I said before, Naomi Kina has been working on, and she's going to continue working on. Keel and I have been working on this idea for a while. You need to know what the impact is in terms of carbon equivalence and environmental impact in order to know if your decision-making process makes sense at that larger global system scale. So this is a tool that we're developing to be used at the early design stage. That's the most important part, because you make decisions then where you've locked yourself into a whole host of environmental issues and technical issues, etc. So you need to be able to assess these things on the front end, not just at the back end. I just kind of went through this, but the tool is also meant to go through the detailed design and construction manufacturing process. So it's a supply chain issue too. It's not just an architecture design issue. And it also has to be used at the end of life stage. So when you're renovating or demolishing or having to dispose of a building, these things have to be accounted for in terms of what the overall global warming potential of a building is. The envelope systems a lot of them are pretty standardized, but our main interest in this is to develop a truly low carbon solution, because right now a lot of the solutions that are in Europe and even here in North America use materials that are very high carbon content. Some of the rigid insulations and all the other water barriers and things like that we want to try to find solutions that are not so high in carbon. Now, our main client in this research program is Société d'Habitation de Québec. The affordable housing and social housing agencies are typically good people to go to for these kind of initiatives, because they're usually owner operators. So SHQ spends over $100 million a year just in energy costs. They have a $1.6 billion renovation budget. So they can do these things at scale. And often these kind of social multi-unit residential buildings for social or affordable housing, or any housing in general, they typically are kind of dumber boxes. I don't mean that in a bad way, because I like dumb boxes. So they're easier to do the renovation of, the retrofit of. The other part of this is that SHQ and Transition Énergétique du Québec have a mandate to solve some of the northern housing problems, and the first task is the deep energy retrofit of the existing building stock. And then I mentioned this before, this is just absolutely critical to Hydro-Québec, because their projections for inundation, flooding, water, energy usage, the electrification of industry, they're going to have some issues here if we don't start actually reducing our energy consumption, particularly at the urban level. These are some of the partners. That's kind of a diagram of the workflow, but the main sponsoring partners are Hydro-Québec, TQ, and some industry partners. Now, finally, I'm going to go through this quick. This is the thing that Grant and I have been working on, and Benoit and Elena and a whole bunch of people. But this is a Canada Foundation for Innovation grant for a new building out at the Mac campus, a research facility to do all the stuff I just talked about. And it's, again, you're going to see a lot of the same words that I used in the previous one, because this kind of came, we put the cart before the horse in a way. Literally, the building came before the research programs in some cases. So we're expecting a decision on that this month, very soon. It's a $19.2 million building, which I think is a bit overpriced, but maybe not now in the current context because costs have been going up a lot. It's basically a big shop where we can prototype and construct things at full scale. It's got some wet labs in it for testing and other forms of research. It's hopefully going to be near the Morgan Arboretum, because the Morgan Arboretum is actually kind of a part of our living lab idea for being out at Mac campus. And it's got the same workflow, you know, research, you develop it, you demonstrate it, and you transfer the technology to the industry, and you do that as fast as possible. And I think that's where the demonstration and the design build thing is so important, because often things stay in the lab and they don't get to the industry until someone actually proves to them that it can be done or that it works. So that's a critical part of our work, of our R&D workflow. And like I said before, we also are very, you know, we need to get probably more involved with the code and policy and the policy making aspects of this thing, but we're starting to make our own headway into that now. These are just some preliminary drawings of it. It's an all wood structure. That funny sawtooth roof actually has a reason for being there in terms of testing passive ventilation techniques and lighting issues, etc. So the way we pitched it to CFI was that the building itself is an apparatus. It's a research tool in itself. And then you've got a really large high bay space where we can move things in and out of that semi-enclosed area outside to keep constructing things year round. A big metal and wood workshop. That's kind of the plan of it. It's a fairly large building, but it's economical on all the toys and stuff. It's nice because a lot of the equipment is going to last for 50, 60 years. So yeah, so that's my 3 initiatives that are all intertwined. So I'd love to hear some questions if you have any.
Great, thank you, Michael. So I was wondering to myself if anybody in our audience does work now or has worked in an industry related to construction. So I'm not going to take a poll, but that's the thought in my mind. So if you have any questions, please feel free to post them in the chat, or if you want to give me a sign, either click an icon so I can see you want to ask a question, or turn on your video and wave at me. So Michael, I do have one question here in the chat asking, when do you think you may be able to begin retrofitting buildings in the Montreal area?
That's a great question. I've been speaking quite a bit with SHQ lately. Listen, the prefab thing and the construction thing, I can do it. Like if we had barn, we could do it tomorrow. We could start tomorrow. It's not like it's not rocket science. You know, we're not SpaceX here. These solutions are fairly well known. The really low carbon ones aren't, but we could start retrofitting. I've already done a retrofit in Philadelphia with a partner. So it's possible to start it tomorrow. The big question is capacity. And SHQ is getting really excited about this, and it looks like we're going to invert our research proposal. We're going to actually start a retrofit at the beginning with SHQ, and then use that as sort of a test. But rather than building up to it through the research, we're going to flip it. because they want to do this at scale. We're talking, they've got like in the slide, I didn't mention it, but they've got almost 90,000 units, you know, doors around Quebec from all the way north to Montreal. And a lot of those buildings were built in the 60s, 50s, 60s, 70s. And they're in, one of the key components is finding the buildings that you're going to renovate anyhow. I mean, if you're going to reclad your home, if you're going to redo your doors and windows, and if you need a new roof, you're probably 70 to 80% there already to doing a deep energy retrofit. And if you need a new furnace, for instance. So the key part of that assessment tool I was talking about at the beginning is that we need to find those buildings. So we're going to be doing a thorough inventory of the SHQ portfolio. We're also working on some methods, probably going to be using some machine learning techniques. We're going to be looking for a grad student, a PhD student that's very interested in that. One of Sal's grad students did it for New York City. He used existing building that was Sal calling me right there. Existing building documents and energy data and things like that. He developed a platform to be able to analyze the building stock to identify, preliminarily at least, the buildings that are best suited for deep energy retrofit. That's a huge time and money saver. And what they found in New York City is that the assessments that were being made were so inconsistent. Some auditors would do a good job, some would do a really bad job. Now here in Quebec, I've already talked to TEQ, the Transition Energy du Quebec people. They're the ones that will administer this program. They already have energy auditors. They have their Reno Clima and Novo Clima programs. What we've talked about is what we developed to replace all of that, because those programs are incredibly ineffective as far as I'm concerned. You know, throwing $3,000 or $4,000 at every Quebecer to redo their windows doesn't actually have that much of an impact. Number one, because that's only one small piece of the equation. Number two, windows and doors are the things that are almost always installed improperly. You lose all of your benefits from them. I don't care if you've got triple pane glass, if you haven't sealed that thing correctly, it's not going to perform. You've just thrown away money, basically. So I think we can start doing it. I actually have anxiety over climate change at this point. So I have dropped all of my slow writing and research sort of activities. I want to build stuff and get it out there and have an impact tomorrow. And most of my colleagues are on the same page with me on that. So I think we'll be able to expedite it pretty quickly. It's, with SHQ involved, they got money, you know, so that's what it comes down to often. And the will, they have the will. And now the political will seems to be there at the federal and provincial level, because everybody's talking about retrofitting our existing building stock. So
Good. Thanks, Michael. So Chris, does that answer your question? Yeah. Were you in construction, Chris? Or we can't hear you.
Okay, sorry. Well, back in college days, I did a little bit of painting and paper hanging, if you want to count that.
Right. Well, thanks for your question. So I did have a question for you, actually, Michael, because you were talking about the need for retrofits that are designed to be specific for a location or even to the point of a building, but also that they need to use prefab solutions. So how do you put those two together?
Well, good question too. It's the pipeline that I talked about before. So you have to go from laser scanning, or actually the thing that I've been developing lately with my colleague in Philadelphia, is a system that's a system within the construction system that allows greater tolerances, so you don't need to have a laser scan, because that's a fairly complicated process and it's costly. So right now, the typical tolerances on the prefabrication panels that you do is 1.5 centimeters. So you have basically a squishy layer in between the panels when you put them on the building. It's an airtight squishy layer. If you could increase that tolerance to say 4 centimeters, then you wouldn't need a laser scan. You could actually do it through more traditional surveying techniques or photogrammetry, which is basically taking photos to create a 3D model. You could get enough precision out of those techniques so you wouldn't have to have that really heavy process on the front end. Then from there, once you have that model and you have your survey points, it just goes into a design for manufacturing assembly process. So it gets automated in the factory. Most Quebec factories aren't very highly automated, but there's one out in Edmonton, there's one out in BC that we're talking to that have a fairly impressive system where it's partially automated. I don't think, look, the company out in Edmonton is probably the most prolific one in Canada. They do new construction. They do 3 homes a day in the factory. That sounds impressive, but in Sweden, they're doing 30 to 40 homes a day in their factories. And those are really highly automated. For deep energy retrofit, it's the Dutch are the one that started the most well-known program. They've got it down now to where they can do the deep energy retrofit of a row house, for instance, in 3 to 5 days. So it doesn't disturb the tenants, and they've got or it doesn't disturb them very much. They've got that process for fabrication down really, really well. And I know what their system is. The problem is it wouldn't work here in Quebec. We have to modify it so it can work with our skill sets, with our building materials, with our supply chains. That's the critical point. I mean, we're not Sweden, we're not Germany, we're not the Netherlands. So we have to work, you go to battle with the soldiers you have, right? So we got to figure that out, and quickly.
Great, thank you. Clarice is asking in the chat. She says she'd love to hear more about the wall assemblies using alternative materials that sequester carbon. And where can we learn more about the wall assembly you showed in your presentation, particularly the options for rigid insulation and air barrier materials?
Okay, that's 2 questions. So, excuse me, the low carbon solutions. So the pandemic sort of derailed this initiative, but there was initiative with the company and the government to set up a wood fiberboard insulation company here in Quebec, which I can't believe I know it's a costly setup for these things. Like, I think in Maine, they're talking about $120 million investment from the government. So it's a serious investment. But we have such high quality wood byproducts here in Quebec that the wood fiberboard insulation is perfect for that. It's durable, it's rigid, it's easy to install, it sequesters carbon, etc. We turn a lot of that material into wood pellets for my smoker on my deck, and that doesn't make sense. So they're coming. The Suprema, for instance, we work with them. They have a wood fiberboard insulation company in Austria. So for barn, they had committed to bring over all of that insulation for barn, but it doesn't make a lot of sense to ship it from Europe. We can still get CLT panels from Sweden cheaper than we can from Nordic here in Quebec. And that's a capacity issue, right? They've got the system down again. They're coming. We've gotten so much better in the last 10 years, even in terms of our supply chain. But we need some more on the ground stuff here. So some of the hemp insulation, for instance, techniques are coming out of more of the West, probably for hemp reasons, but those are actually really getting a lot better, and they're finding alternatives to a lot of the chemicals that you have to put into like formaldehyde and such for insects and things. So there's actually a great company up in the Gaspé that use borate to to, which is sort of more, it's more of a natural process. It's not so toxic for wood, mostly for termites and things like that, but they're also turning that into treating certain types of insulation like cellulose and such. So, you know, you have to be aware of these things. You have to find the right mechanisms to actually inspire and promote them. In terms of the wall assemblies, or the different kinds of wall assemblies, there's a lot that are readily available out there. I mean, in terms of the diagrams and things like that. When it gets tricky these are all exterior panel retrofits, by the way. If you have to, like we were working on the schooling environment to do a deep energy retrofit from the interior, and that's a lot more complicated process. And there's no real way to automate that or to make it more efficient like you can with the exterior. So depending on the construction method, there are typically it's a wood frame construction method. Those solutions are out there. They developed a few at the Natural Resources Canada in Ottawa, who are one of our partners. But then there's another company out in Vancouver called Nexi, and they've developed a Portland cement-free concrete. So it's a low carbon concrete system for doing panels for more like high rises and new construction. They just got a huge contract with Starbucks to do all of their buildings now for the next 10 years. It's a pretty cool system. The problem is that they're using a foam insulation. It's like a structurally insulated panel system, and that foam, it's the best of a bad choice. You know, it's still really high in carbon content. So those are the kind of solutions that we want to try to figure out, you know, like where are the other options? And we've got some good companies in the area actually that are looking at it as well.
Great, thanks. We have another question from Jeremy asking, when do you anticipate your carbon assessment tool to be ready?
It's Naomi's already developed sort of a prototype for it. The Rhino plug, that one of them is actually a plug-in that you, so we use 3D modeling programs to do what we do. They're building information modeling programs. That's the standard now for architecture. We don't really draw anymore. And those programs all have they have plugins that go with them. So for the most common one is called Revit. It's an Autodesk product. It's the industry standard. Most governments require you to draw on it, model in it. One of our colleagues, again in Philadelphia, works for a firm called Kieran Timberlake. And Kieran Timberlake has a research division, and they developed a tool for Revit for LCA assessment, life cycle analysis assessment on the front end. It's called Tally. So we know that's out there, and we're going to keep working with them to develop it further to include some more energy related analyses. So a little deeper accounting of the carbon and the effects of that. The plugin that Naomi developed is called Clark's Crow, and it plugs into Rhino, which is the program that's most common in schools of architecture and in some firms. You can't use it for the legal documents so much, but it's a good design tool. You typically design in that, and then it goes into Revit, which is the more production tool. So we have versions of these tools already under development and by our own faculty, and our colleagues. So I think that we're going to be able to expedite that quite significantly with this NSERC grant. And we also have contacts with Autodesk out of Toronto quite closely that I think we can actually get into more of development pipeline with them.
All right. So again, I invite people to post questions in the chat, but in the meantime, I do have a question for you, Michael.
Mm-hmm.
Something that I've been pondering, because you and your colleagues are promoting more intensive use of timber and wood construction materials. So what do your friends, the forest ecologists, say about the potential impact on our standing stock of trees if we start to use them for building?
Great question. So one of our current PhD students, for instance, working with Benoit Cote, and one of the things we want to do, and which he's starting to do with Benoit, is to use the Morgan Arboretum as sort of a ground truth. So they're doing a full assessment of the Arboretum to understand, trees sequester carbon to a point, right? As soon as they fall down or start to deteriorate, then they release the carbon. So the management of that, what Peter's question, Peter Osborne is the PhD student, and Keel Mo is working, he's his advisor. There's a question as well, okay, can we somehow synchronize those forestry management cycles with the construction industry? So we sequester as much carbon as possible. So we harvest when we need, we harvest when it's most appropriate and most effective in terms of sequestration. And we also build when those cycles are coming around, or at least we transform the wood into, whether it's wood fiberwood insulation or CLT panels or structural timber or whatever. If we can synchronize those things, there's a lot of sequestration optimization that can happen. Then of course it's just part of the larger forest management kind of questions that are not my area of expertise, but in terms of planting, replanting, one of the things as an architect that it's been heartbreaking. We're not replanting with some of the best wood because it's slower growing, right? So we're planting a lot of white pine instead of red pine. It's worse down in Georgia and in the States, and it has a huge consequence for architecture, because like that wood, if you're harvesting wood in like 20, 30 years with these loblolly pines, for instance, the structural capacity of all that wood is going down. So then you have to use more wood, so like literally the industry every year evaluates the structural capacity of standard produced wood coming into like Home Depots and whatever. It has been going down every year, like dramatically for the last 20 years, because we're planting basically crappy wood. And so again, that has another effect, because then you just have to use more of it to get the same structural, performance out of it. So you're not really, it's great for their business, I guess, but in terms of carbon, you're not. So I think you just have to do it responsibly. You have to manage it, and that's a huge question. It's also about maybe the industry right now is producing a lot of crappy 2x4s that you see at Home Depot, right? It might be an issue of just moving that production into more mass timber kind of elements, because the codes are changing. We're able to do 10, 12, 13 story wood buildings now. And that's huge because it's around 70–80% of the carbon in any given building is in the structure. And if it's a concrete or steel structure, that's a 70–80%, right?
Good, thanks, Michael. So I just want to give an opportunity, if anybody wants to ask a question orally, if you want to unmute yourself. We're not a big group now, so if you want to just unmute yourself, you can even just hold down your space key for a little while to unmute yourself, and you can ask Michael directly. Don't be shy.
Hi, Michael.
Hi, Arlene.
I'm just wondering if you think that building integrated photovoltaics have a role to play in low carbon prefab. It's not very timber oriented, but as you said, urgency is in the game right now.
That's an awesome question, and that's one of the ones that really prompted me to get into this area of research, because again, go back to the cobalt question. It's mined by hand by poor kids in the Congo. Okay, we find cobalt primarily in batteries in electric vehicles, but also solar panels. Those are the two main, right? So if you're in Quebec and you have hydroelectric power, for me, it doesn't make any sense to have a solar panel unless there's an energy security issue. if you're off grid or you have unstable grid connections or whatever. One of our, I mean, René Levesque was brilliant. One of our greatest civic assets, despite all the biodiversity damage. I mean, we know all this now, but now that it's in place, we have a hydroelectric power. So if we're considering carbon in the here and now, a PV panel never pays itself off in terms of carbon costs. Okay, or they're estimated to have a 19-year life cycle. All right, the amount of energy you save in terms of carbon costs in Quebec never equals that you spend on the actual hardware itself. Then you've got all the other issues around recycling and etc. So now, with that said, if you're in Arizona and you have huge, you don't have a lot of hydroelectric power, you've got a lot of wind and a lot of solar, it starts to make sense because you can do it also at a scale where you can actually have it integrated into the grid, a smart grid. And so you're getting a bi-directional exchange on it. And so you're able to reduce peak. The one benefit of batteries and solar panels in Quebec is the fact that we could manage the peak demand of the energy grid.
We could do some load shifting. We could do some load shifting. I do.
Yeah. It's huge concern of Hydro-Quebec. I mean, 15% of Hydro-Quebec's energy supply is used 5% of the year. Okay, so they've designed the system for the peak. If they could lower that, they would not only save literally tens of millions of dollars every month, they could design the system completely different and distribute it completely different to be a hell of a lot more efficient. So the peak, this is one of the main concerns of the deep energy retrofit. You know, like if you live in a passive house level building, if the power goes out in the middle of the winter, you're still good for 3-4 days without any power, with just bodies in the house, right? So that's resilience. That's true resilience. But like the house we did in China, we worked with Hydro-Quebec on that too. And we actually developed an app because that did have PV panels because it was required for the competition. We developed the app where the building took itself offline during the peak periods. And it could because it was so super insulated and airtight. And like I've been in passive house buildings that in Philadelphia and Vermont that have never had to turn on their heating system. The appliances, the bodies, the computers, all that was enough to heat the house. So, I mean, that's what the deep energy retrofit's goal is to get to that level. So you just don't have, if you just don't have to consume energy, you don't have to produce it either on site, I'm saying.
Thanks for that.
Yeah.
Great. Thanks, Michael. So we're at the top of the hour here. And Chris, I saw your hand.
Chris had a question.
Before we go to Chris's question, I'd just like to, first of all, in the interest of keeping our schedule, thank Michael very much for taking the time to talk to us this evening. It was a great talk, fascinating discussion. And for those of you who have to leave us now, I wish you a good evening. I hope we'll see you back again for the Food for Thought lectures next fall. I'm going to stop the recording, but we can stay in the Zoom room and we can keep chatting for a little while if that's your pleasure. So once again, thanks, Michael, and thanks to the audience.
Well, thank you. Thanks for the invitation.